The IT threat landscape is shifting rapidly. Information security professionals acknowledge it's no longer a matter of if they'll be the victim of a breach, but when. Like the threats themselves, the tools that organizations use to detect and respond to these threats must evolve. And more organizations are turning to security information and event management, or SIEM solutions, to stay ahead of these threats. In this webcast, leading experts from Gartner and LogRhythm reveal how a comprehensive SIEM solution substantially improves an organization's ability to detect and respond to advanced threats and breaches more quickly and accurately than ever before. We'll also find out why big data analytics are playing an increasingly important role in the equation. And we'll hear from the Director of IT Security and Compliance at a large Midwest electric and gas utility on why her organization turned to LogRhythm's SIEM 2.0 solution for advanced threat detection and response, as well as compliance automation and assurance for a myriad of regulatory mandates.
The biggest change in the threat environment has been the rise in successful targeted attacks. A targeted attack is directed at a specific organization with a specific goal in mind, usually to steal data that is of competitive value, or to drain an account of cash, or to steal information about a company's customers. Targeted attacks unfold differently each time. Many of them start at a weak spot. A popular weak spot might be an employee of the company. They may be the subject of a spear phishing email, for example, with a malicious attachment or a URL pointing at malicious code on a website. The idea is to establish malware on the endpoint, establish a surveillance point so that credentials can be stolen and then used to directly access applications in the environment. It doesn't have to start with the user. It may start with a web-exposed application that has vulnerabilities, or a web-exposed system with vulnerabilities, or by some other means. The user endpoint combination is becoming an easier target with the rise in employee-owned devices, because the security organization has no control over the security state. However the attack starts, the environment is gradually traversed along an attack path that varies with each attack until the ultimate goal is achieved, which is, the data or the account. The first order of business is to present a hard target to the attacker. Many of these targeted attacks are in some ways opportunistic. If there are 4 or 5 companies with the same type of data or the same type of target, if one company is security hardened and another has many vulnerabilities, the attacker is going to take the path of least resistance and go for the weaker environment. So presenting a hard target to the attacker requires a combination of things. It requires perimeter protection that's properly configured, firewalls, IPS systems, and so on. It requires a vulnerability management program that's effective at finding and fixing vulnerabilities on servers, applications, networking equipment, and so on before that vulnerability is exploited. And it requires various types of shielding technologies to shield vulnerable applications and systems until they can be fixed. Now, one problem with vulnerability management is you reach a point of diminishing returns. No matter how much money you spend, no matter how disruptive you are to the environment, there are still going to be applications that can't be patched, systems that have long-standing vulnerabilities for one reason or another. We're losing control of the endpoint, as I mentioned earlier, so there's going to be vulnerabilities there. And users will always be tricked into giving up their credentials or clicking on that malicious attachment. So if we can't achieve perfect defenses, then we have to be good at early breach detection. These attacks take time to unfold, so there is time to discover a targeted attack in its early phases and stop it before the data is stolen. Unfortunately, there's a lot of room for improvement studies like the Verizon data breach study that are renewed each year, they show year after year that about 90% of the time there's early evidence of the breach in the log record, but only about 10% of the time has anyone noticed it. So there's a lot of room for improvement. Effective early breach detection requires security monitoring that covers user activity, network activity, data access, and system access. These events need to be combined with context. Context about the user. What is the user's role? That tells you something about the expected resource access for that user. If it's server monitoring that's being looked at, or server activity that's being examined, context about that asset. What is that server used for? What applications are running on that server? What data sits behind the system? Because that tells us something about a potential target. If it's data access that's being monitored, then we need to know something about the business use of that data. In addition to this type of context, it's also important to know something about the vulnerability state of the system or the application. Are there security weaknesses present on those components? And a more recent development in this area is a growing appreciation for the importance of threat intelligence or threat context. If an organization is doing the user activity monitoring, data access monitoring, system access monitoring, and application activity monitoring that I just described, and combining it with the user asset data context, the last piece is knowing something about, let's say, the IP addresses of known botnet control sites, or having a watch list that contains URLs of websites that have malicious code. With that type of context, it's more likely that someone will be able to spot the small amount of abnormal activity that's the signal of a targeted attack. Profiling and anomaly detection is needed to augment the traditional rules-based correlation that has been deployed by SIEMs in order to make the technology more effective in early breach detection. With rules-based correlation, you set up tests for known bad conditions ahead of time and then get alerted when those situations are satisfied. The problem is that targeted attacks take a path, an attack path that's different each time, and so you don't know the exact conditions ahead of time. Profiling and anomaly detection takes a different approach. There's a learning period, so the environment is monitored over a period of time, and profiles are built on various boundaries like users, server activity, data access, network access, and so on. When the boundaries of normal are exceeded in some way, an alert is generated. So with profiling and anomaly detection, you don't have to know ahead of time the conditions that are going to be present for a particular targeted attack. You can rely to some degree on the profiling to generate alerts when abnormalities occur that are the signal of a breach. SIEM technology implements many capabilities that can be ascribed to big data. There's a requirement for high levels of scale in terms of ingesting events from a wide variety of sources in real time at very large data rates, processing that data, normalizing it, and then writing it to the backstore, but also monitoring the event stream in real time so that alerts can be generated or the profiling that we described earlier can be accomplished. What we've seen as a much stronger requirement associated with targeted attack detection is also the ability to quickly analyze the data in the backstore. In many SIEM deployments in the past, there was large-scale collection and real-time monitoring, but once the data hit the backstore, there was only very modest access to it. Now, in the context of an investigation related to a potential targeted attack, a security analyst needs to pivot through the data, needs to be able to rapidly run a set of queries to zero in on something in order to determine if this thing that's sort of gray that just happened is a big problem, or whether it's just, you know, something that is looked like a problem but really isn't. So early breach detection puts a lot more emphasis on the rapid analysis of a large amount of historical data, something that has stressed many older SIEM deployments of late. The functional capabilities required by a SIEM to be effective at breach detection are high-scale ingest of a large amount of event data from a wide variety of sources, the ability to combine that event data with context about users, servers, applications, and data, and to also include context about the vulnerability state of IT components and threat intelligence. We also talked about the need for high-performance analytics to allow someone to quickly pivot through the data in order to investigate a potential breach. What we haven't talked about is how an organization needs to deploy this technology so it can be effective in accomplishing these things. And the security organization typically owns the project and is responsible for monitoring oversight, but they need some help. You need to involve domain experts, people that know something about database administration, Unix server administration, Windows administration, network authentication, and so on. And the reason you need these people is because they are the ones that are most likely to be able to eyeball a report and notice that something is not normal. You can't depend on automation completely. You have to have smart eyeballs on reports. Give you an example. If someone knows something about database administration, they're going to be the most likely to be able to look at a database administrator activity report and make a determination, make a judgment that that activity that they're seeing looks like a maintenance job or it doesn't. And if it looks like a maintenance job, they may be able to just do a sideward glance over to the change management system to see if a change has been approved on that system at that point in time. That's the type of monitoring that is also needed in order to have the best possible chance of discovering a breach. So it's important for the security organization to involve these other areas, to identify responsible people, distribute targeted monitoring reports to those individuals to have the best possible chance at early breach detection. Here's a real-life example of how the monitoring technology is supposed to work, how it could be effective in early breach detection. I was talking to the owner of the SIEM deployment from a large bank, and they were using the SIEM in a typical way, broad scope security monitoring, and they had been alerted by the SIEM to some abnormal network authentication activity. So the SIEM alerted them to an abnormal condition. They pivoted through the data and determined that this was in fact something serious, but they couldn't complete the investigation. They weren't exactly sure of the ultimate target of this attack. So what they did is they took the data from the SIEM and brought it over to their fraud detection unit, who was doing application layer monitoring, and between the two of them, they put the data sets together, so now I've got two sets of smart eyeballs on reports. They did figure out that they were partially breached, and they were able to determine the ultimate goal of the attack, and it was early enough for them to disrupt it and prevent data loss. So that's an example of how the technology can be used to, in an automated way, draw someone's attention to an abnormal condition, and then the security staff and domain experts taking the next steps and doing analytics to ultimately discover the extent of the breach and the ultimate target of the breach.
Today, organizations have a real challenge. The threat landscape is evolving rapidly, and many companies have realized it's really more a matter of when versus if they will be breached. And as such, they've taken much more of an approach around ensuring they can detect that breach early when it likely will occur and respond just as quickly in terms of containing an eventual eradication. Our technology has really been designed to, address this new landscape that our customers find themselves in. And it really started with, kind of our fundamental approach to architecture and how we built Logarithm. And we built it to really converge many technologies that were previously disparate into a single, kind of cohesively integrated solution that was designed to really be accessible, easy to use, but still deliver all of this capability and all of this power. And I'd say that it starts with a platform that was built on a log management foundation. The ability to collect, every log, every flow, every event that is generated across the enterprise, and then to be able to present all of that data to advanced analytics engines that can look across all of that data to find what is truly meaningful, truly what represents true risk within the organization at any point in time. And we've also added other capabilities into this single integrated platform, such as file integrity monitoring and deep visibility onto target servers through our host activity monitoring. The result of this architectural approach has allowed us to identify those events, those issues that represent highest risk to the organization, eliminating some of the challenges in first-gen solutions, really specifically around false positives. If there's too many false positives, it all becomes a noise. So we need to get to the true positives, the things that we really care about. And we also need to get to the true positives that today or previously were invisible within the enterprise. You couldn't see. And again, this architectural approach that we've adopted, allows us to not only, root out, and eliminate the false positives, but also really see more things that are actually happening within the enterprise, things that we were previously blind to. And that's really critical today, because if you can't see it, you can't respond to it. And that's really fundamentally a challenge a lot of organizations are really concerned with. Companies have a real challenge. I mean, the reality is most organizations, don't actually know if they've been breached. I believe the most recent Verizon data breach report said that 90% of organizations actually didn't detect themselves that they were breached. Somebody else found out for them. That's 90%. That's not the right trend. So. How do we do better than that? Behavioral analysis, is one of the key ways in which we're going to do better. When the threat landscape is changing as rapidly as it is today, a signature-based approach, by itself just isn't going to be solely sufficient. We have to also be looking at, what is normal within the enterprise. What does a user normally do when they come to work every day? What does a host containing cardholder data do every day? What other hosts does it communicate to? What other locations does it communicate to? Where's data sent? Who logs into it? If we can understand these behaviors around users inside the network, hosts, that are sensitive, that are, the targets, of a breach in most cases, we have a chance then at identifying when a breach has occurred. Because if a breach has occurred, it's going to be often through an account that's been compromised. When an account is compromised, it's going to exhibit different behaviors. It's no longer that same person, it's somebody else. It's an imposter. They are not going to use that account the same way the authorized user would. We can see that, we can detect it. Same thing with the host. If a host gets compromised, accessed by what appears to be a compromised user, begins to exhibit different behaviors on the, on the network within the environment, we can see that as well, we can flag it. And I think that is, that is a critical weapon, that organizations need to have at their disposal today to have a chance at finding out if they've been breached, and also, if there are threats from within that they need to be concerned about. And I think if you're not looking across all of this data and not trying to understand what is normal and identifying when things are clearly not normal, you're really going to miss. You're going to miss a lot, and chances are, you might get breached and you might miss it. At LogRhythm, we've really taken a different approach when it comes to analytics. It was really one of the key reasons why I started the company with Phil. It was to achieve a grander vision on the analytics side. And it starts with the notion of we have to collect it all. We have to analyze it all. Every log, every flow, every event needs to be collected, needs to be analyzed. If you're not doing that, you've got blind spots. There are parts of the data that are incomplete. If it's incomplete, you can't ask questions of it. That's kind of the point with analytics, the ability to ask the questions you want to ask and get good answers. Another area where we really look to invest and be different was what I'd call a multidimensional approach. One of the downfalls with with correlation, behavioral analysis in the past has been false positives. And how do we eliminate false positives? We do it through what I refer to as corroboration. The ability to look across multiple dimensions of what's happening within the enterprise to get to a highly corroborated event. We can look across what's happening at the user layer, at the application layer, the host layer, the database layer, the network layer, and we can infuse across all of that context, internal context, as well as external context. And once we have access to all of those layers, those dimensions, that allows us to get much more accurate in terms of what we're actually then again asking of that data, because we can look across not just one behavior, we can look across multiple behaviors for a given host, a given user. I'd say the other, and maybe a little bit less technically exciting, but really critically important, is just usability, accessibility. One of the downfalls, I think, of correlation of analytics, as a whole in the SIEM market has been it's been so complex. In some cases, overly complex. It's been unusable, inaccessible to the to the customer, to the market, in that the technology is deployed holds great promise, but it's so complex to actually create a rule describing the question you want answered, the correlation you're looking for, the behavior you're looking for, that the result is the user gives up or they can't maintain it. So we put a lot of time in making our technology actually user-friendly, accessible, easy to manage, and easy to leverage the expertise that we provide out of the box through our LogRhythm Labs team. They can take our experience, our knowledge within labs and easily customize a very complex rule looking for a correlation or behavior, and easily map that to their environment. And then that's critically important because in the end, the analytics I think holds great promise. It's the future of the space in many regards. But if it's inaccessible, it's not usable, it's no good. And that's been a key objective of ours. Maybe to go back to the multidimensional and give an example of that. Why is that important? If we look at behavioral analysis, behaviors are hard to model. It's hard to know what normal is. I can look at what maybe a user does on a certain basis, on a daily basis, or maybe model things such as where am I seeing remote authentication from for a given user. If I see a change in that, do I flag that? Is that enough of a change to be an event? In first-gen solutions, it might be. Challenge might be a lot of false positives. Somebody's on a business trip, they go out of town, they travel overseas. I get an event when it really wasn't an event. Another example of behavioral analysis might be, how many files a user accesses on a daily basis, and just kind of building a trend across that. Do they access maybe 100 files, 200 files, 1,000 files? Maybe I can model that and alert if I see a deviation around file access by itself. But again, I might get false positives. If we can use more of a multi-dimensional approach and combine those two behaviors together, where I can say, I saw an anomalous authentication attempt for this user, an odd location where they logged in from. Then I saw that same user an hour later download an extremely anomalous amount of files from the file server. Now I've got two very suspicious behaviors for the same user. And I think that's a good example of kind of the multi-dimensional approach. I'm not observing just a single behavior deviating. I'm seeing multiple behaviors deviating within a short time frame for the same user, maybe the same application, same host. And that's how we get to a highly corroborated event, a true positive that really requires somebody's attention and represents true risk to the organization. And so I think that gives an example of the multi-dimensional approach. Kind of leveraging our the three key differences that I see that we've brought to market around next generation analytics. Seeing all the data, no blind spots. Multi-dimensional analytics. And then lastly and critically, making the technology actually accessible, usable. I love talking about big data and security analytics because it's something that we've actually been doing for a long time in SIEM. The amounts of data that we've been collecting and analyzing, processing has been big data for a long time, and I guess with security, it's a little bit different than maybe traditional big data. Where a lot of that is kind of after the fact. Looking at data at rest, after, it's been generated. With security, we need to do that certainly. We need to look after the fact and be able to go in and support and get to root cause and, and get to the forensic trail around an incident. But that's not enough. It's got to be real time as well. We've got to be looking across all of this data, all logs, all flows, all events in real time, to root out high risk events. That have compliance, security, operations concern, and so I think that's one of the unique things around SIEM when we talk about SIEM and kind of the convergence of big data is it's not just kind of the after the fact analysis and search. It's also the real time analytics piece. And it has to be real time. If we talk to some of our large enterprise customers, they've got challenges in this area. They've got all this data, and how do I figure out what's normal? How do I put all of this data to use now? And we've been very successful in helping our large enterprise customers make sense of this data, find things in the data that they simply just could not see before, they were blind to. We've detected custom malware, botnet infestations that had been there, for some time until, we were put in place and began to look at that data the right way, and actually see what was happening. We've got customers that have used our technology to detect fraud, and you're looking at some large banking customers looking at transaction activity, patterns, behaviors in that area to root out fraud. Some retail customers doing the same thing in terms of looking at point of sale systems from a fraud standpoint. But I think the point is that we have all of this data. There's this tremendous opportunity now where we have access to all enterprise, machine data, logs, flows, events. And when we have access to it, we can now ask a set of questions we could never ask before, if we have the ability to ask them the right way. And that's our approach. is making sure that we have the analytics capability, to ask the right questions the right way in real time to get to the answers, that are most critical to enterprises today. Am I breached? Do I have a insider threat? Do we have an operations concern, or issue which could be a pending outage that could cost, tens of thousands, or more money? Or do I have an issue which could become a serious compliance violation? We have the opportunity now to, in real time, see these things, identify them as exceptions, and raise them to, the eyes of the appropriate people and management, so we can help to, reduce risk in areas we simply couldn't see before. When evaluating different options in the market for a SIEM solution, there are a number of critical things to look at. One, the platform itself. Was it really designed to be a single, integrated, cohesive solution, for addressing your needs? Does it have integrated log management, event management, file integrity monitoring, host activity monitoring, and does it work well together? Or alternatively, is it kind of a collection of parts, that maybe wasn't really designed, up front to really be a single solution, but is being kind of forced there. I think that's critical. I think also, is it designed to collect all the data? Is that how it was fundamentally built? And was it designed to collect all the data in a single kind of cohesive manner where it's consistent? The data is classified in a meaningful way across all of the data. That enables easy, consistent search, reporting, analytics. How's the data being treated long term from an archiving standpoint? Is there actually a thoughtful approach to storing this data for years, if that's the requirement, and making sure that you can recover it years later and validate that data hasn't been tampered with or modified, since the moment it was written? We've put a lot of thought into that part of our technology, and I think it's actually often overlooked by buyers, in making sure that if they get a request from a law enforcement agency in terms of, give us logs from 6 months ago, you can actually do that and be comfortable that that law enforcement agency will take it and be able to, to use it. On the analytics side, I think what's critically important, and actually is, I think, a downfall of first-gen solutions. Are you looking at all of the data? Are you looking at it in real time? Or make sure what's not the case is that when you're correlating or applying analytics, it's against a subset of the data. It's against maybe just the exception-based layer, those things that are already somewhat interesting. That really just is not good enough. Real-time analytics need to be applied against the entire universe of log flow and event data. It just fundamentally has to be that way. I think then you need to look at, from an analytics standpoint, well, what questions can be asked now of this, this big data, all of this, log flow and event data. What can I build from a correlation standpoint, a pattern standpoint? What can I describe? And how easy is it to describe within my organization in terms of the the usability of the tool? Look at the behavioral analysis capabilities. Is it multidimensional in nature? Can you look for behaviors via different techniques? For example, can you use automatic whitelisting? To whitelist normal and expected process activity on a host, or authentication activity on a server. Can you apply histogram trending, rate trending, average trending? The reality is there are many different ways to ask a question of this data. You need to ask it the right way. Make sure you have those options. That there are multiple methods of actually asking a behavioral question. And then I can also ask and look for multiple behaviors that are either correlating or combined together around the same user, the same application, the same host, all deviating together to get to a highly corroborated event. Because in the end, we need to get to true positives. If you can't ask the question the right way, if you have blind spots, you're not going to get to that point. You're going to have false positives, or you're going to have false negatives, even worse. There are going to be things happening in your environment that you're not going to see through a lack of visibility. I think another area, is compliance, and the compliance feature set. Compliance is critically important. So I think, understanding, what is being delivered out of the box in satisfaction of your PCI requirements, HIPAA, Sarbanes-Oxley, etc. How much coverage will I get with this purchase? Not all products are created equally in this regard. Some solutions, you can get a lot of coverage for your dollar. And make sure that the manner in which you're going to get that compliance coverage in terms of how it's delivered by the vendor is easy, it's manageable. What's actually delivered out of the box? And is it delivered by a reputable research group within that company? Have they invested in hiring ex-auditors, ex-analysts, people who have a deep expertise in understanding the requirements themselves, how to look for exceptions and events within this data, and have they packaged it up for you in a way that makes it actually easy to deploy, easy to maintain, so that you can leverage their expertise, get to compliance quickly, get to value quickly. And I think the same thing is true, beyond compliance as well. Do they have a research group? For a logarithm, we have a team called Logarithm Labs. That is our team of security experts, ex-auditors, CISSPs. That produce content, we produce modules that help our customers very quickly leverage our solution set within their environment at a very low cost of implementation and maintenance for them. So I think it's that out of the box value. I think that's critically important. And then I think just in general, is it usable? We talk about the analytics side. All this great power, ability to ask all these questions. Can you actually ask the questions? Or is the technology so obtuse, so complex, so sophisticated, you can't actually achieve that? So you have to look at the ease of use side, because if you can't actually leverage all of this great power, all these solutions have a lot of opportunity and things that they can do, but if it's not usable, if you can't actually put it to use, it doesn't matter. So you need to evaluate, is it accessible? Is it usable? Am I going to actually be able to realize the full benefit of this purchase?
I'm the Director of IT Security and Compliance at LG&E and KU Energy. We are an electric and gas utility based in the Midwest, serving over 1 million customers. About 2 years ago, we decided that we needed to look for a more robust SIEM solution. We had a first-generation logging solution in place, and that wasn't scaling to our needs in terms of compliance. So we looked at something that could give us the ability to comply and also the ability to alert on security events. We had multiple requirements for the SIEM solution. The first was, of course, to be able to alert on security incidents. The second was to enable us to comply with the SIP regulations. And the third was to enable us to demonstrate that we had complied with the SIP regulations. In order to do this, we used the requirements gathering document from Gartner and went through and customized that to our requirements. We also looked at paper research on a lot of different vendors. We went through the Gartner Magic Quadrant and selected multiple vendors that we wanted to do research on. And we spoke to customers and looked at some demos. Based on that, we down-selected to 3 vendors. And with those 3 vendors, we went through a proof of concept. We brought in their equipment into our environment and spent a month, approximately a month each, on looking at the product in our environment and looking at how easy it was to use and how the team was able to use it during the POC. Based on that, we went ahead and sent an RFP out to 3 vendors and went ahead and selected Logarithm. The products that we looked at all had some level of similar capabilities, but what made Logarithm stand out for us was that the AI engine capability seemed very robust, and based on our conversations with other customers, it seemed like it had a lot of capability that we could use. And the second part of it was the support that we received both from the pre-sale staff as well as the support staff during our POC. As you can imagine, we ran into issues during the POC, and they worked with us through those issues and got us to where we needed to be. So we felt very comfortable with the support that we would receive were we to buy the product. As an electric utility, we have a pretty large network, and we have a wide variety of operating systems and networking devices within our environment. Logarithm is used for collecting logs from all of those different systems, including our control systems and SCADA systems. The SIP regulations require us to really gather a lot of information, and without a system like Logarithm in place, it would have been unduly burdensome and actually pretty much impossible to do and get all of our data together and then be able to demonstrate that we do have that data. We went through an audit recently, and as part of that audit, we were required to produce a lot of logs to show that we were logging at specific points in time. And Logarithm came through for us, and we were able to get all of that data demonstrated to the auditors. So definitely invaluable to us that we were able to do that. We've been very pleased with the support that we've received from Logarithm. You're a growing company, and obviously there has been some change of technical staff over time as we work with you all, and we've been pleased with the quality of every one of the people who has worked with us. So very, very happy with that.